Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 10, part 2, from the May-June 2017 Cambridge International A-Level 9709 paper 1. This is the Pure Mathematics 1 component, and I've already answered part 1 in a previous video, which was all to do with solving trig equations. Now I'm going to do part 2, which is more related to functions and inverse functions, so I'm going to save them in separate playlists for the topics and the same playlist for the paper. Now, here we're asked to first find an expression for the inverse of the function of f and find the domain of the inverse of f. Okay, so just one little point about the wording of this question. Technically, if the question said find the inverse of f of x, if it was just find the inverse of f of x, nothing else except for that, then both of these things are implied in that question, that you should find the expression for it and you should state its domain. Especially if the original function has some restriction in it, then the domain will be affected by that. So if the question just said find the inverse of the function, then it implies that you should find the expression for the inverse as well as its domain. Okay, sometimes I've noticed at Excel they do ask that question without stating, separately like this. Just say find the inverse of f of x, and there is a marker sign for the domain as well. So it's something you should be aware of in case you get a question like that, that you should find the expression as well as the domain, even if it just says find the inverse function. Okay, if it says find an expression for the inverse function, that means you don't need to put the domain, but if it has that in addition, of course you do. All right, now, so the expression for the inverse function. Now we know to find the inverse of a function, we first just name the function y. So y equals 3 times the tan of a half x minus 2. And then I like to ask the students at this stage to replace the x with the y and the y with the x. Some students do that at the end, right at the end when you finish, which is fine, but many times students forget to change it at the end, and they give the answer in terms of y in the end, and they lose a mark. So now what we got to do is we got to make y the subject. So what we should try and focus on in this case here is we should try to make this term, this tan half y, the subject of this formula. Okay, first, and then we can deal with what to do after that. So the first step is to make this a subject. So I'm going to add 2 to both sides. So I have 3 tan of a half y. And then I'm going to divide both sides by 3. So I have x plus 2 over 3 equals the tan of a half y. And now what I can do is I can take the inverse tan of both sides of the equation. I need to get this y as a subject. It's trapped inside the tan function. So I'm going to take the inverse tan of both sides. That will cancel the tan on this side. You're left with a half y, and this side will be inverse tan. So I'll be left with a half y is equal to the inverse tan of x plus 2 over 3. And then I can just multiply by 2. So y is going to be 2 times the inverse of tan of x plus 2 over 3. And there we have our expression for the inverse function. Okay, that's the answer for part 2, the first part of it, the expression. Okay, so now we got to find the domain of the inverse function. Now we know that the domain of the inverse function, is the same as the range of the original function. And the range of the inverse function is the same as the domain of the original function. That's something that we should know. They switch around. The x and y switch around as we've done here, right? So, in fact, I should write this as, therefore, the inverse function of x is equal to 2 times the inverse of tan of x plus 2 over 3. Just write it in there Make it clear that that's the inverse function f of x. Okay, so for us to find the domain of the inverse function, what we could do, one method we could use is think about the range of the original function. Okay, now I like to think about domain and range in terms of, visually. How does the graph look? How can we sketch the graph to find the range and the domain of the function? Okay, it's always a sensible thing to do with these type of functions. So what I'm going to do is I'm going to actually start answering part 3. Okay, before I finish this part 2, I'll come back and then write the answer down, because part 3 is all about sketching on the same diagram the graph of y equals f of x and y equals inverse of f of x. So I'm going to start by sketching the graph of y equals f of x as part of my answer for part 2, and I'll extract from that what I need to write down the domain of the inverse function. So I'm going to draw this function here for this limits, and then I'm going to work out its range. And then I'll write the answer down. The range of this function will be the domain of the inverse function. And then I'll sketch the inverse function, and then we'll be finished. All right, so now let's think about what this graph will look like. I'm going to draw a pair of axes first. Make that a bit thinner. So I'm going to draw a pair of axes. Okay, so here's the y-axis, here's the x-axis. Okay, now what we know is, if we start, I'm going to start with y equals tan of x. Y equals tan of x. And then I'm going to go through all the transformations until we get to this particular graph, all right? So if you have y equals tan of x, we know that we have an asymptote at pi over 2 and at minus pi over 2. Okay, so there's an asymptote here, minus pi over 2, make it a bit thinner. You have an asymptote here, and I have another asymptote somewhere over here, right? So at negative pi over 2 and positive pi over 2, you have asymptotes. Okay, that's has been radians, minus 90 and 90 degrees. Okay, so that's x equals pi over 2 and x equals minus pi over 2. All right, so now what happens when we have, so the tan curve will look something like this. Okay, it will look something like this. I'm just making a sketch of it. Okay, so that's y equals tan x. Now we got y equals tan of a half x. We always start with what's inside the function. So the first, y equals tan x, that's drawn. Second, we're going to do y equals the tan of a half x. Now, the tan of a half x is a horizontal stretch of factor 3. Okay, the tan of factor 2, sorry. Or factor 2. We're talking about 3. Just make that near. A half x, and that's of stretch factor 2, which means all the x coordinates are multiplied by 2 and the y coordinates stay the same. So what I'm going to do here to make it a bit easier, I'm going to just say that this is now going to be, instead of pi over 2, it's going to stretch horizontally, but to make it easier to draw, I'm just going to change the values of this. This now becomes pi minus pi, and this becomes plus pi. Okay, because the asymptote has now moved twice as far away from the, x being stretched horizontally by a factor of 2. So I've just changed these values, so it's basically showing it. I've kind of stretched the axis rather than the graph, right? Just for ease sake. In the end, we have to have everything in the right place. It's fine to do that. That's no problem. Okay, it's not any scale that we're drawing it to. And then it says the next part of this would be 3 times, so you have y equals 3 times tan of a half x. Now, what does the 3 do? Okay, the 3 gives you a vertical stretch of factor 2. A vertical stretch of factor 2. So it doesn't affect anything except for the y coordinates of this. So there's nothing really for us to show in this graph. The origin, the place where it crosses the y-axis won't be affected. It doesn't cross the the x-axis here as well. It doesn't get affected. So nothing gets affected except for this will be a bit steeper. All right, but I can leave it like this because there's no scale here that we have to draw it to. It's just a sketch. So I'm just going to leave it as it is. It will still have this kind of shape to this particular kind of scale. All right, then the next thing that happens, well, this is the third thing actually, that was the original, is this minus 2 bit. So it has 3 times the tan. So y equals 3 times the tan of a half x, and the minus 2. Now the minus 2 represents a translation of vector 0, -2. So here the y coordinates are all reduced by 2. So it has the same shape. I'm just going to draw this. Has the same shape as this, except what happens is it just gets dragged down 2 units. Okay, something like that. Get rid of this part. Okay, so it looks something like this between minus pi and pi. However, our domain of this original function, the domain of the original function is between minus pi over 2 and pi over 2. Okay, so I have to get rid of everything less than negative pi over 2 and everything more than pi over 2. Okay, so what I'm going to do is I'll just redraw it slightly. Okay, everything greater than pi over 2. Okay, so I'm going to have something like this. Let's say pi over 2 is here. And minus pi over 2 is here. So it's going to be between those 2 points. Okay, everything out of that interval is now going to be, taken away. That was a bit too big anyway. All of this is going to be taken away from it. And you're left with something that looks something like this. Okay, so this is the point pi minus pi over 2, and this is the point pi over 2. So basically, what I can do is to find the range of the function. The range of the function would be between these values here. The range of the function would be between this value and this value for y. So it's going to be between that point and that point. That would be the range of the function. Okay, that's the range of this function, and that would therefore be the domain of the inverse function. So how do I find this point and that point? Well, I just take the original equation. I know that y equals 3 times the tan of a half x minus 2. So let's find out the y value when x equals negative a half. When x equals negative a half pi, we've got y equals 3 times the tan of, it's going to be a half times negative half, which is minus pi over 4 minus 2. And the tangent of minus pi over 4, as we should know, is negative 1. So you have y equals negative 1 times 3, which is negative 3 minus 2, which is minus 5. So I know that this is a point minus pi over 2 and negative 5. So that's negative 5. And I know when x equals pi over 2, then y equals 3 times the tan of positive pi over 4 minus 2. Now the tan of positive pi over 4 is equal to 1. 3 times 1 is 3, so you've got 3 minus 2, which is equal to 1. So we know that this is the point here, pi over 2 and 1. So that means the range of our function, the range of f of x, or f dash of x, or range of f of x is basically between minus 5, including minus 5, up to 1. That's the range of f of x. So therefore, that will be our domain of the inverse function. So drawing this here helps us to answer this question here. So we can see, okay, so the domain we can say of f of x is, sorry, the range of f of x. Okay, can we say the range of f of x is between minus 5 and 1. Therefore, the domain of the inverse function is between minus 5 and x. We call it x for the domain is always called x. The range is f of x or y. So here the domain of the inverse function is between minus 5 and 1. Okay, so there's the answer for the domain, and we got the actual function itself, and there's the answer for part 2. And you can mention, okay, shown on part 3, shown in part 3 if you want. All right, so now what's left for us to do, so we kind of, in answering this part of the question, okay, we do a sketch, so we kind of answered most of the next part of the question. What they're asking us now to do is to also sketch y equals the inverse of f of x. And what we know is that the inverse functions and the original functions, they kind of like, they swap over. So they basically the x and y values are swapped over. So for this graph, instead of going through minus pi over 2 and minus 5, okay, the inverse function will go through minus 5 and minus pi over 2. Okay, so it's going to be something over here. This is not really to scale. And it's going to kind of like cut through the x-axis. And it's going to be somewhere over here where the other part of it is going to be, which will be when you've got, instead of pi over 2 and 1, it will be 1 and pi over 2. Okay, and instead of, as we said, this would be minus 5, and this would be minus pi over 2. Okay, so it'll look something like this. It's going to have this type of reflected shape. Okay, so it's going to be like this. Okay, and something like that. It's not going to go through, it looks like it's going through minus pi over 2, but it's not. So what I'm going to do is I'm going to move that slightly across. Okay. Let's make me move that a bit this way so that it doesn't look like it's passing through that point. Okay, so it's a bit difficult actually to draw this kind of properly. All right, so something like this. I mean, basically, it's a reflection, as we can see, in the line y equals x. Okay, it's a reflection in the line y equals x. It's not really that well drawn because everything's not to scale, but I think that would be perfectly acceptable. Look, something like this. Okay, it's a bit difficult to draw it. You'd have to be a bit more accurate with your placing of the values, like, you know, pi is 3.14, so maybe we could do it a bit more slightly to scale, but that would be fine. So if we just put the coordinates of the endpoints, that would probably be a good thing. So this would be basically 1 and pi over 2, and this would be minus pi over 2, so minus 5, sorry, and minus pi over 2. This would be minus 5 and minus pi over 2. Okay, so these basically, the x and y coordinates are switched over. And as we can see, we don't have to draw it here, but as we can see, you can say the line, or these two are reflection in the line y equals x. Okay, the reflection in the line y equals x. Okay, so here we have, this is y equals f of x here. And here we have y equals the inverse of f of x. And as we can see, the domain is between -5 and 1 for this function. Okay, which is the same as the range of this, which is between -5 and 1. So I've tried to draw it to the best of my ability. It's a bit of a mess here, but hopefully that helps you to understand what to do and how to do it. So that concludes this question, which is question number part 3 from question 10 of the May-June 2017 P1 paper from Cambridge. Other questions from this particular paper can be found in the playlist that will appear over here, which includes part 1 of this question, which I made on a separate video. Other questions from this topic of functions and inverse functions, yes, will be in the playlist over here. That will include functions and transformations and functions and so on. And I will also put it in the playlist for trigonometry as well, okay, because it's got some things related to sketching tree graphs. And if you'd like to subscribe to my channel, you can subscribe. In fact, I'll put another, if you'd like to find if you'd like to subscribe to my channel, you can click on this link over here. And if you watch the video that is linked on the card at the top of the video, during the video, that will show you how to use my channel to find what you need, whether you're doing Edexcel, Cambridge, whether you're doing IGCSE. It'll help you to navigate through my channel and find what you need in an efficient manner. Thank you for watching, and see you soon.